Hey guys, if you watched our video yesterday, then you saw that we did an anchor chart about different kinds of angles. And we talked about how there are 4 kinds of angles that we're going to be looking at. And I wanted to point this out to you. This is something that you have in your packet that was sent home. Okay. This is your geometry vocabulary. This has all the words for all of the geometry things that we would learn for all of 4th grade. Okay, it's a lot. A lot of these you already know. So I don't want you to see this and go, oh my goodness, I've got to know all these words. You know most of these words. You already know polygon and quadrilateral and rhombus. Some of these are words that you learned all the way back in 1st grade. Square, rectangle, okay? We are going to be talking about 4 of these vocabulary words for the next couple weeks. So I want you, if you have a highlighter, great. If you don't, take your pencil and underline it, or take a crayon and kind of color over it, whatever you need to do to be able to keep up with these words and easily find them when you need to. So here are the 4 words. Down at the bottom of this first section, it says right angle. I want you to highlight or underline that word. Put a little star beside it, something so that when you look at this paper, it's going to pop out to you. Right angle, obtuse angle, acute angle, and I really wish they'd put this one with it, but over here, straight angle. Those are the 4 angles that we added to our anchor chart in the last video. Now, you also have kind of an anchor chart that was included in your packet. I like to draw mine because I can use pretty colors, but if you want to look at this one too, it goes over those same 4 types of angles that we've been talking about. I know my camera has a shadow there. We'll ignore that for a minute. So it has straight angle, right angle, acute angle, and obtuse angle. So if any point while I'm teaching this, something is confusing or doesn't make sense or you don't remember, first thing I want you to do is to go back and look at these 2 papers. Okay? And say, oh, I forgot what an acute angle is. Go back and read the definition of it. Go back and think about it. Go back and watch my last video. Okay? Then, if it doesn't make sense, you can holler at any of us teachers and we're more than willing to help you with it. Okay? But I wanted to show you in your packet where you could find some hints so you're not getting frustrated or worried if you don't understand something. What I'm going to do is I'm going to go through a couple of these angles more specifically. We're going to really look at a couple of them. So today we're going to look at these 2 angles. Okay, we're going to look at a straight angle and we're going to look at a right angle. So I want you to get out your notebook or a piece of paper or wherever you're writing these things down and have it ready because that's what we're getting ready to do. Okay. This camera is going to drive me crazy. I wonder if there's a way for me to, maybe not. Okay. All right, so we're going to be looking at right angles. In your definition that I just showed you, and we're going to write it again because the more we write something, the more it sticks in our brain. A right angle I know that's blurry. It'll clear up. There we go. Measures 90 degrees. And a right angle looks like this. Now, don't panic if you see a right angle that looks like this. Okay? You might see a right angle that looks like this. It doesn't matter the direction it's turned, just like a triangle. It doesn't matter if it's a long and skinny triangle or a short and chubby triangle. It's still, if it has 3 straight sides, a triangle. If this has a corner or an angle that measures 90 degrees, it is still a right angle. It does not matter the direction that it's turned. Okay? So every single time, and remember I showed you this little tool in the last video. Right here is 90 degrees. Okay? So if I were to draw, and I don't have a ruler with me, I wish I did. Well, I have one, but not a little one that will fit in here. So let's say we go from here to here, as straight as I can get it, and over. What that tells me is when I move my protractor, I have created 2 rays that where they connect make a 90-degree angle. So this angle is 90 degrees. Okay? This angle is 90 degrees. This angle is 90 degrees. This angle is 90 degrees. I want you to stop what you're doing just a second and find a window. The corner of the window, 90 degrees. The corner of our doors are 90 degrees. The corner of the piece of paper that I'm writing on is 90 degrees. That's one of the reasons I wanted to start by talking about this one. You will find this type of angle everywhere. Okay? It's very, very common. I'm looking around the room I'm in right now and trying to find some other things that would be right angles. Here's a Post-it note. It has a right angle. It has 4 right angles, actually. Because it is a square, squares and rectangles have 4 right angles. Let's see here. Oh, these little decimal cards I've used before, they're a little curved. If this was a corner instead of a curve, that would be a right angle. Let's see. Oh, our fraction tiles that we've worked with in the past, those have right angles on the corner. They are everywhere. Okay? And start paying attention to that, because another one of the pages that you were given has an angle scavenger hunt. I'm going to come back to this in another video and talk to you about some ways we can find these angles. But just start looking for them. Okay? So here today, right angles. So this doesn't seem that tough, and it's not. Anytime we see an angle that comes to a corner like this, like an L, it measures 90 degrees. It is a right angle. Now, I am going to try to trick you a little bit because, well, that's the fun. So here we go. I'm going to draw another right angle, but I'm going to leave out a piece, and that's where you are going to be the detectives who are going to help me. Maybe my pen works. I'll grab a different pen. My lines are not perfectly straight, but we will pretend like they are. So, for all purposes, this is a perfect right angle, which means, because, I know that right angles measure 90 degrees, that this is 90 degrees. Right? Well, that wasn't hard. I'm not done. I'm going to trick you. I'm going to cut this angle into 2 smaller angles. Do you see this? So now I have a little angle here, and I have another angle here. I have an acute angle here and an acute angle here because they're both smaller than 90 degrees. I'm going to tell you that this angle is 45 degrees. And I'm going to ask you, this is gone because I split that in half. It's not 90 anymore. This one is 45 degrees. And I'm going to ask you, what is the measurement of this angle? How in the world would I figure that out? So I want you to take just a second, and I'm not going to give you a lot of time, but if you need time to think, click the pause button, think about it for a second. Is there a way we could write an equation to figure this out? Can we look at this as a part-whole problem? When I look at this, I know that this whole angle, the one created by these 2 rays, equals 90 degrees, right? Because every right angle is 90 degrees. When I split it, I now have 2 angles, right? One of them is 45 degrees. What is the measurement of the other angle? Okay, just like any other unknown problem, we are going to figure out 45 plus what equals 90. And the easiest way to do this is 90 take away 45. I can do that vertically. If I have no ones, I can't take away 5 ones. I'm going to decompose a 10. 8 tens and 10 ones. 10 take away 5 is 5. 8 take away 4 is 4. 45 degrees. So half of a right angle, if I split it into 2 equal pieces, they would be 45 degree angles. 45 plus 45 equals 90. Okay, I can do that on any angle I want. So we're going to try on one more problem. Okay, I'm going to draw a right angle. And I'm going to split it here. And I'm going to tell you that the measurement of this angle is 74 degrees. And I'm going to ask you, what's the measurement of this angle? Now, I could be very nice and hold the protractor up to it and actually measure this and see, but I'm not going to do that. I'm going to make you use some math. So how can we find an unknown part of a right angle? We have to take what we know. What do we know about a right angle? A right angle has a total of how many degrees? Right, a total of 90 degrees. If a right angle is 90 degrees, and the first part that I have is 74 degrees, what is the measurement of the second part? 74 plus what would give me 90? And I can do that vertically again. I could skip count if I wanted to. Okay, either way you choose to do this is fine. I know that if I have 0, I can't take away 4. I'm going to decompose a 10. It gives me 8 10s and 10 1s. 10 take away 4 is 6. 8 take away 7 is 1. The measurement of this little angle is 16 degrees. Now I want you to notice something here. The numbers that go with the angles match the size of the angle. You see that? 16 degrees is a smaller angle than 74 degrees. Okay, I want to show you actually with measurement where they're going to be more correct than the ones I just did. I want to show you. So I'm going to draw a straight line here. And I'm just going to draw a measurement. I'm not using the protractor here. I'm just drawing this to show you. Okay. If I showed you these two angles, here is an angle and here is an angle. And I ask you which one of these angles has a greater measurement or which one of these angles is bigger, you're going to look at the actual corner here and tell me which one is opened up more. Because remember, the closer it gets to that perfect square, the closer it's going to be to 90 degrees. So here's 0 degrees, 1, 2, 3, 4, 5, all the way up until it was a straight line and it would be 90. I'm going to measure these and I'm going to actually show you which one would be bigger. But I want you to see you can also look at them and tell by the visual. Okay? All right, I want you looking. All right, so I'm going to measure this angle. I'm going to take the corner. Let me flip over the yeah. Take that corner and put it. Make sure my straight line on my protractor is following the straight line here. And I'm going to finish out my angle. I didn't give myself a lot of room there. So this goes 50, 60, 70. Do you see how it's counting by tens? That means this would be 55, and my line would fall between the two. Okay? So my angle measurement would be 50, 51, 52 degrees. 52 degrees. Okay, everybody see how I did that? We're going to be doing a bunch of these, and when I get to see you all again, I will put some of these protractors in your hand, and we will actually get to practice some of them. This one's a lot easier to read. I know I'm going to grab another piece of paper so you can see underneath here what I'm talking about. Okay, so I take that little angle, I put the vertex in the corner, I follow my straight line, and look, it lines up perfectly here. Okay, so this angle is going to measure, here's 10, here's 20, here's 30. So this line is 25 degrees. So this bigger angle is 52 degrees. This smaller angle is 25 degrees. Okay, and remember this full, I'll try to actually do this straight. This angle, where it looks like a square, is your 90 degree. So the further the angle moves to this position, the bigger the measurement is going to be. Think about the temperature with degrees. The hotter it is, the more degrees it measures. The bigger the angle is, the more degrees it measures. Okay, so all we did today is we looked at right angles and how they compare to other angles and how we can split them into smaller angles. Next video that we do, we're going to be talking about the same thing, but how it looks as a straight angle. And we'll pull back out that definition and talk about straight angles next time. I love you guys. Stay safe.